High above Earth in the cold and endless dark, a giant structure moves quietly. It does not make a sound. It does not slow down. It does not stop. It circles the planet again and again, like a guardian watching from the sky. This giant is the International Space Station, a superstructure unlike anything humans have ever built. And yet most people on Earth never look up to think about it. From the ground, it appears only as a bright dot crossing the night sky. But for those who know its secrets, it is much more than a bright dot. It is a city in space, a science laboratory, a home for astronauts, a symbol of human teamwork, and above all, a machine that never sleeps. As sunlight hits the station's massive solar panels, they shine like huge golden wings. These wings collect the energy that powers the entire labyrinth of modules, robotic arms, and scientific machines. From a distance, the ISS looks like something from the future. Long rectangular panels, connected tubes, bright metal, and shapes that almost look alive. But every part of this superstructure has a story. And every story begins with a simple truth: the ISS should not be possible. Why? Because this structure is not on Earth. It is floating 400 kilometers above the ground, in a place where no human can survive without support. The temperature can change from burning hot to deadly cold in minutes. There is no oxygen, no air, no water, and even the smallest piece of space dust can tear through metal at enormous speeds. Yet the ISS moves through this danger like a giant ship on silent waters, a ship that travels 28,000 kilometers per hour, a ship that completes an orbit around Earth every 90 minutes. As it travels, Earth rotates slowly beneath it, blue oceans, white clouds, and dark continents passing one after another. To astronauts inside, the world appears in flashes. One moment they are over Africa. 90 minutes later, they are over the Pacific Ocean, then the Arctic, then Europe, then night, then day again. This rhythm never stops, not for a second. The ISS is always moving, always running, always alive. A superstructure born from the impossible. The story of the ISS is not just a story of engineering. It is a story of human determination. Before it was built, many people believed that creating such a structure was impossible. Some said it was too expensive. Others said it was too dangerous. And many scientists believed that humans could not survive in space for long periods. But the dream was too powerful. For decades, space agencies wanted a long-term home in space, a place where humans could live, sleep, work, and study the universe without returning to Earth again and again. A place for experiments that could not be done on the surface. A place that would one day help humans travel deeper into the solar system, perhaps even to Mars. This dream became reality when 5 of the world's most powerful space agencies decided to work together. NASA, United States, Roscosmos, Russia, ESA, Europe, JAXA, Japan, CSA, Canada. Together, they agreed to build the largest and most complex structure ever assembled in space. But there was a problem. A very big problem. The ISS was too large to be built on Earth and launched as one piece. So engineers came up with a bold idea. They would build it in space, piece by piece, while orbiting the planet at 28,000 km/h. Imagine trying to screw together metal parts while floating, while spinning around the Earth, while wearing a giant spacesuit, while holding tools that could fly away with a small push. It sounded impossible, but the engineers believed in it, and the astronauts took the risk. This is the beginning of the ISS. The moment when a dream became a mission, and the mission became history. A home between worlds. From the outside, the ISS looks cold and metallic, but inside it is full of life. Astronauts float through long, narrow corridors, pushing gently off walls to move from one module to another. They sleep in small personal spaces that look like phone booths. They drink water that is recycled from the air. They eat food that is stuck to trays so it does not float away. The station is more than a machine. It is a home between worlds, between Earth and space. For astronauts, life inside the ISS is strange, exciting, and sometimes even funny. Without gravity, everything floats: food, tools, water drops, even people. A simple task like washing your face becomes an adventure. But living without gravity also comes with challenges. Muscles grow weak. Bones lose strength. The body changes in ways scientists are still trying to understand. That is why the ISS exists, to learn how humans can live far from Earth. To learn what happens when gravity disappears, to prepare for future missions to the Moon and Mars. But before any of this could happen, the ISS needed to be built. The strange beauty of the station: when seen from space, the ISS looks alien, like something that should not exist. Yet it also looks strangely beautiful. Its symmetry, its long solar wings, its modules glowing white in sunlight, it almost looks like an insect with metallic legs floating above Earth. The station is roughly the size of a football field. It weighs almost 420 tons, more than 320 cars combined. And yet, it floats effortlessly because it is in constant freefall around Earth. Every detail of this structure was designed for a reason. The solar arrays collect power from the sun. The pressurized modules provide oxygen and temperature control. The truss segments hold everything together like a giant skeleton. The robotic arms move equipment, cargo, and sometimes even astronauts. The docking ports allow spacecraft to attach and bring supplies. The radiators release heat into space. But the ISS did not look like this in the beginning. In fact, it started as only a small module, a single room floating alone in orbit. Over the years, astronauts added more modules, more panels, more systems, until the ISS became the superstructure we see today. A machine that can support 6 or more people at once. A machine with enough power to run hundreds of experiments. A machine that never turns off. A day in the life of the ISS. A day on the ISS is different from a day on Earth. There is no sunrise, no sunset, no morning, no night. Instead, astronauts see 16 sunrises and 16 sunsets every 24 hours. The station orbits so fast that day and night come and go like flashing lights. Inside, everything is controlled by strict schedules. The ISS has a heartbeat, a rhythm. Every beep, every light, every tiny vibration tells astronauts that the station is alive and working. There are systems that check oxygen levels, systems that check temperature, systems that track pressure, systems that protect the station from fire or leaks. If something goes wrong, alarms ring loudly, echoing through the metal corridors. Astronauts must respond fast. There is no outside help. They cannot call 911. They cannot leave the station unless they board a spacecraft, and that itself is a risky move. This constant tension is part of life on the ISS. The endless view. Perhaps the most incredible thing about the ISS is the view. Astronauts often say that the first time they look out the window, they feel something change inside them. Suddenly, the world looks small. Borders disappear, countries blend together, oceans look endless, clouds move in slow, beautiful swirls. From the cupola window, the famous viewing area, astronauts can see the entire Earth curve beneath them. They see lightning storms from above, see city lights glowing at night. They see polar ice shining like diamonds, and sometimes they even see shooting stars below them. This view reminds astronauts why they came to space. It reminds them why the ISS is important, and it reminds them that Earth is fragile. A giant that never rests. The International Space Station is more than a science lab, more than a home, more than a machine. It is a symbol of what humans can achieve when they work together. It is proof that we can build something beautiful and powerful even in the harshest environment known to man. Every day, the ISS orbits Earth like a silent guardian, watching, studying, learning. It shows us that humans are not meant to stay on one planet forever. It shows us that our future may lie beyond Earth. It shows us that the universe is waiting. The ISS is not just a superstructure. It is a promise that humanity will continue to explore, a promise that we will reach farther than ever before, a promise that the stars are not out of reach. When the International Space Station was first imagined, many experts believed it was only a dream too big, too risky, too expensive, a dream that would require machines humans had never made before and teamwork the world had never seen before. But the world decided to try anyway, and what followed was one of the greatest engineering challenges in human history. It began with a simple idea: build a city in space, but build it one piece at a time, while orbiting Earth at 28,000 kilometers per hour. No blueprint on Earth had ever attempted something like this. No astronaut had ever assembled a large structure in orbit. No country had ever joined forces for such a massive space project. Yet, one by one, the pieces of the dream started coming together. The first stone of a space city on November 20, 1998, the first piece of the ISS was launched into space. It was a small module called Zarya, which means sunrise in Russian. Zarya was not large. It did not have living space or giant solar panels, but it had something the ISS needed more than anything: power and control. Without Zarya, nothing else could be added later. This tiny module was the foundation, the first stone of a future superstructure. Once Zarya was in orbit, another module was launched. Unity, built by the United States. Unity was like a connecting bridge. It had ports on different sides, allowing more modules to attach in the future. When Unity finally docked with Zarya, the world celebrated. Two pieces from two different countries coming together in space. And that moment marked the start of an engineering revolution. The race begins every year after that. New pieces were prepared on Earth: solar panels, laboratories, robotic arms, life support systems, habitat modules. Each piece had to be carefully wrapped, protected, and loaded onto a space shuttle or rocket. The strange part, none of these pieces were ready to work alone. Every module depended on the next one. It was like building a puzzle where each piece floats in space and you must join them while wearing a 150-kilogram spacesuit. Engineers on Earth watched their screens nervously as astronauts in orbit slowly connected the modules. Every bolt mattered. Every cable mattered. Every seal had to be perfect. If a tiny mistake happened, the module could leak, fail, or even explode. Yet the astronauts performed their mission with calm professionalism. They pushed forward, step by step, building a structure no one had ever seen before. The art of spacewalking outside the ISS, spacewalks were the most dangerous part of construction. A spacewalk is not just a walk. It is a battle against silence, a battle against cold, a battle against the vacuum of space. Astronauts floated outside the ISS in bulky white suits that protected them from deadly radiation and temperatures nearly 150 degrees C hot in sunlight and minus 150 degrees C cold in shadow. Their movements had to be precise. Tools had to be clipped to their suits so they didn't float away. Even the smallest mistake could send a screwdriver drifting into the dark forever. When astronauts moved outside the station, the Earth spun below them in a blur of colors, blue oceans, green forests, white clouds, but they could not admire the view for long. Every second mattered. Each spacewalk lasted 6 to 7 hours, 6 hours of twisting bolts, 6 hours of connecting wires, 6 hours of using robotic arms to lift heavy objects in zero gravity, 6 hours of pure focus. Sometimes they worked until their fingers hurt inside the gloves, until their voices cracked from speaking through the helmet radios, but they kept going, because they were not building a house. They were building a legacy. The day when everything could have failed, there were days when things almost went very wrong. One time, a small leak appeared in one of the modules during construction. The pressure inside the station started dropping. The astronauts acted instantly. They closed off the module to save the rest of the structure. Ground teams worked through the night searching for solutions. Another time, a power system refused to start after installation. Without power, the entire section of the ISS would be useless. Engineers on Earth sent updated commands, rebooted systems, and ran emergency sequences until finally, after hours of tension, the system powered on. The station lit up again. And then there were the micrometeoroids, tiny rocks, some smaller than a grain of sand, rushed through space at incredible speeds. Even though they were tiny, they could punch holes in metal. Several times, astronauts discovered dents or small cracks on the solar panels or radiators. These were fixed with patches or new surfaces. Every repair taught engineers something new. Every failure made the station stronger. When the universe helped build the ISS grew piece by piece. Solar arrays unfolded like wings. European and Japanese labs arrived. Canadian robotic arms stretched out and started helping astronauts move cargo. The structure became longer, wider, brighter. It started to resemble the superstructure humanity had imagined years earlier. What surprised many scientists was how the environment of space actually helped the construction. In zero gravity, heavy modules felt light. A person could move a multi-ton piece with just their hands. Large structures did not need cranes or scaffolding. Long truss segments could float perfectly still in place. Gravity, for once, was not the enemy. It was simply not there. The universe itself became part of the construction team. The moment the ISS came alive finally, after years of launches, spacewalks, and engineering miracles, the ISS began to take shape. It no longer looked like separate pieces but a single connected machine. Its systems woke up, lights turned on, fans started running, computers started syncing. Air flowed through newly connected tunnels. The station felt alive, and when the first crew entered, something changed forever. Until then, the ISS was only a machine. But the moment humans stepped inside, breathing its air, touching its walls, working in its laboratories, it became a home. A home that floated above Earth. Teamwork across nations. Perhaps the most beautiful part of this story was not the metal, or the bolts, or the machines. It was the teamwork. The ISS showed the world that countries could work side by side, not as rivals but as partners. American astronauts worked with Russian cosmonauts. European engineers connected their labs to Japanese modules. Canadian robotics performed delicate tasks that human hands could not. The station became a symbol of unity, a symbol of what humanity could achieve when it lowered its borders and raised its vision. A city in orbit by the time the main construction was finished. The ISS was huge, 73 meters long, 109 meters wide, 420 tons heavy, with more living space than a 6-bedroom house. And powered by a solar array larger than a Boeing 787 wingspan, it was now a true city in orbit. One that never touched the ground, never landed, never stopped. Inside its walls were laboratories, crew quarters, exercise rooms, storage areas, command centers, airlocks, docking ports, windows. With the best view in the universe, the ISS had become the most expensive structure ever built. And yet it was priceless. But a hidden problem was growing. While the ISS was growing, while nations were shaking hands, while astronauts were celebrating their success, something else was happening quietly. Something no one expected. Something dangerous. Something that would not reveal itself until years later. Every time the ISS orbited Earth, it passed through invisible clouds of space junk, broken satellites, old rocket parts, tiny fragments of metal. The amount of debris increased every year, and the station was now flying through a cosmic minefield. Scientists began to worry. The ISS could dodge large objects, but small pieces, moving faster than bullets, were almost impossible to track. One day a small piece would hit the station, and on that day the ISS would face one of its greatest threats. A threat that no one yet fully understood. A threat that would change everything. Far above Earth, inside the walls of the International Space Station, life follows a rhythm that no human on the ground can truly understand. To the people on Earth, the ISS looks like a distant star gliding across the night sky. But to the astronauts living inside, it is a world of its own. A floating home where every second is planned, every movement matters, and every mistake could bring danger. For anyone who enters this metal world, the first moments feel strange. When an astronaut passes through the hatch and floats inside the station for the first time, the mind becomes confused. There is no floor, no ceiling, no up, no down. Everything floats: food, tools, pens, cables, even astronauts. Inside this new world, gravity is only a memory. And yet life continues, not like on Earth, but in a way humans had to learn from the beginning. A day without morning or night. Most people start their day with sunlight, but on the ISS there is no real morning. The station races around Earth every 90 minutes, which means the astronauts see 16 sunrises and 16 sunsets every 24 hours. When they look out the window, the world glows with colors they never imagined. But the rise and fall of the sun comes too quickly to follow. So astronauts live by the clock, not by the light. Every day begins with a wake-up alarm from mission control. The crew slowly opens their eyes, not in beds but in small sleeping cabins. These cabins are like vertical phone booths with zip-up sleeping bags tied to the wall. Inside these bags, astronauts float like cocoons, drifting a little as they sleep. There is no tossing and turning. There is no falling off the bed. The body simply floats in peace. But once they open the hatch of their sleeping area, the workday begins immediately. Eating in zero-gravity breakfast inside the ISS is not like breakfast on Earth. There are no plates, no steaming pans, no fresh bread, no cups filled with hot tea that can be carried through the room. In zero-gravity, liquids become danger. They float away as spheres, sticking to cameras, wires, screens, and even eyes. So astronauts drink from sealed pouches with straws. Their food comes in sealed packages that must be cut open carefully. Even the easiest meal becomes a lesson in physics. When they take a bite, the food doesn't fall back onto a plate. It floats. So astronauts must eat quickly, catching pieces of their meal before they drift away. Sometimes they laugh as a small piece of scrambled egg drifts into the air. Other times, they chase floating crumbs with a vacuum tube so they do not clog the station's filters. Food becomes entertainment. Food becomes challenge. Food becomes science. And yet, even in this strange environment, eating together becomes a moment of peace, a reminder of Earth, a reminder of home. Floating through the day, once breakfast is done, astronauts begin their daily tasks. And these tasks are unlike anything on Earth. Every astronaut has a schedule planned minute by minute. They move through modules like fish swimming in water, pushing off walls gently with their fingertips. A small push can send them drifting across the room. They grab handles to stop themselves, then push again, moving from one module to another. Some astronauts run experiments, studying how fire burns in zero gravity, how plants grow without soil, how metals melt without falling, how the human body changes when weight disappears. Others check the systems of the station: air filters, water recyclers, pressure valves, electrical panels. Every machine inside the ISS is important. If one fails, life inside the station could be at risk. Floating is easy, surviving is not. The body remembers gravity. Living without gravity sounds fun. Everything floats. Movement is easy. There is no weight, no heaviness, no pressure on the feet. But the human body is designed for gravity. And without it, the body changes in ways that surprise even scientists. Muscles grow weak, bones lose calcium, hearts pump differently. Blood moves upward, making faces look round and puffy. Astronauts can become dizzy, they can become tired, their bodies grow confused. So every day astronauts must exercise for almost 2 hours. It is not a choice, it is survival. They run on treadmills with straps that hold them down. They use machines that simulate lifting weights, even though there is no weight at all. They cycle on a bike that floats in the air. As they exercise, sweat floats off their skin in beads, drifting away like tiny pearls until a cloth or fan catches them. This workout is the only thing that keeps their bodies strong enough to return to Earth one day. The beauty of the window, the ISS, is full of machines, cables, computers, and scientific devices. But there is one place every astronaut loves the most: the cupola. The cupola is a dome-shaped window on the station's side, made of 7 crystal-clear glass panels. Through this window, astronauts can see the entire Earth pass beneath them. They see storms from above, city lights glowing like constellations, mountains covered in snow, oceans shining like blue liquid glass. Many astronauts say the cupola is the most emotional place in the entire station. Some come here to relax after a long workday. Some come to photograph Earth. Some come to remember why they came to space in the first place. From the cupola, Earth looks peaceful, soft, and beautiful, so beautiful that astronauts sometimes cry quietly as they float, watching the world below rotate like a fragile crystal ball. Here they understand something powerful: Earth is small. Earth is delicate. Earth is all we have. The constant danger behind the walls. Life inside the ISS may seem peaceful, but danger is always present. Station is surrounded by vacuum, an environment where a tiny puncture can mean disaster. Astronauts know the risks. They train for emergencies constantly. There are 3 main threats. 1. Loss of pressure. A single crack or hole in the wall can let air escape. If pressure drops, alarms scream loudly. Crew members must seal off the leaking module in seconds. 2. Fire. In zero gravity, fire behaves strangely. Flames float, grow in circles, and burn unpredictably. Smoke doesn't rise. It forms deadly clouds. 3. Toxic leaks. Some machines use chemicals that are dangerous if released. If they leak, the crew must put on masks and isolate the air. The astronauts are never relaxed, not fully. They live in a place where danger hides in silence, and yet they continue day after day, learning, exploring, surviving. The mystery of the strange sounds. For years, astronauts have reported strange sounds inside the ISS. At night, when the station enters the shadow of Earth, the temperature changes quickly. Metal expands and contracts, pipes click, panels shift, air pumps hum. Sometimes astronauts hear knocking, soft taps that seem to come from the walls. Of course, the sounds are natural. Of course, the engineers explain them scientifically. But when you are floating in darkness, surrounded by nothing but endless space, even normal sounds feel mysterious. Some astronauts say the noises feel like the station is alive. Others say it feels like the emptiness outside is knocking, waiting. A warning appears on a normal day inside the ISS. Astronauts move through their schedules like always. Experiments run. Cameras record, tools float. Laughter echoes through metal corridors. But on one particular day, something unexpected happens. A small notice appears on one of the station's screens. It is from the ground team. It is short. It is simple, but it changes the atmosphere inside instantly. The message reads, "Possible debris incoming. Impact risk elevated. Prepare for avoidance maneuver." The astronauts look at each other silently. They know what this means. A piece of space junk, something sharp, fast, and deadly, is racing toward the ISS. If it hits the station, even a tiny fragment could punch a hole through the walls. The ISS has avoided debris before, but this one is different. Smaller, faster, harder to track. They have only minutes to act. The crew floats quickly to their positions. Mission Control begins calculating a new orbit. The engines prepare to fire. And in that tense moment, as alarms glow red, one astronaut notices something that makes their blood run cold. A tiny new crack on one of the station's windows, a crack that was not there yesterday. The mood inside the International Space Station changed the moment the warning appeared. A machine that usually felt calm and predictable suddenly felt tense. Lights glowed red, screens flashed, and every astronaut moved with silent urgency. The threat from space debris, the tiny fragment rushing toward them, was real. But the tiny new crack on the station's window was even more disturbing. Still, the ISS continued its purpose. Even in danger, it was a place of discovery. A place where humans learned secrets about life, technology, and the universe that could never be understood on Earth. While engineers on the ground calculated an avoidance maneuver and the crew waited for commands, the astronauts kept working. Because inside the ISS, experiments cannot stop. They run around the clock, floating machines, glowing tubes, spinning chambers, and boxes filled with data that could one day decide the future of humanity. And it is here in these experiments that the ISS holds its greatest secrets. The science of weightlessness. One of the first things astronauts learn inside the ISS is that nothing behaves the way it should. Flames dance in floating balls. Water forms perfect spheres. Plants grow in strange directions. Human bodies weaken. Metals melt in ways scientists never expected. Weightlessness reveals rules that gravity normally hides. Inside a small experiment module, water is pushed out of a tube. Instead of falling, it forms a round bubble that floats like a tiny planet. Astronauts gently push it with their fingers, and it wobbles as if it is alive. Sometimes they inject color into it and watch the dye twist beautifully inside the sphere. These experiments are not just for curiosity. They help scientists understand how liquids behave in zero gravity, how fuel moves inside spacecraft tanks, how blood flows through the human heart, and how life might survive during long journeys to Mars. What happens in these floating laboratories changes science forever. The fire that behaves like a living creature on Earth, fire rises, flames stretch upward, smoke climbs to the sky. But on the ISS, fire becomes something else entirely. In a sealed experiment chamber, scientists ignite tiny flames. The astronauts watch safely through a protective window. Inside, the fire burns not like a sharp tongue of heat, like a glowing blue sphere. It floats calm and quiet, almost like a breathing creature. There is no smoke, no upward movement, just a round, silent orb of fire. This strange behavior teaches scientists how fuel burns in space, information that is critical for future spacecraft, engines, and life support systems. But some flames behave differently. Sometimes the fire grows without oxygen, forming a mysterious cool flame that burns almost invisibly. The astronauts who see it say it feels like watching something supernatural, a fire that should not exist, yet does, and scientists still do not fully understand why. Growing plants without soil or sunlight, one of the most important goals inside the ISS is learning how to grow food in space. On long missions to Mars or beyond, astronauts cannot carry years' worth of supplies. They must grow their own plants. Inside the ISS, small gardens float under glowing LED lights. The plants grow in careful rows: lettuce, herbs, dwarf tomatoes, and small flowers. Water is fed through tubes because in zero gravity it doesn't soak into soil, it just floats away. These plants grow more slowly, their leaves curling in strange patterns. Roots do not know which direction to grow, but still the plants survive. Some even thrive. Astronauts talk to them, check their leaves, and sometimes, when the experiment allows, they harvest them and taste the fresh greens. Eating something alive in space, something not dehydrated or packaged, feels emotional for them. But the plants also reveal something deeper: how life might one day exist on a space station orbiting Mars, or inside a base on the Moon, or even on another planet. The ISS is not just a laboratory. It is a rehearsal for the future of humanity. The human body, the greatest experiment of all. While machines and plants teach us much, the most important study on the ISS is the human body itself. Every astronaut is an experiment. Their muscles weaken, their bones thin, their immune systems shift, their hearts change shape, their blood moves upward, filling their heads and pressing behind their eyes. Some astronauts return to Earth with vision problems that last for months or years. Inside the ISS, special machines scan their bodies, measure their breathing, track their heartbeats, and monitor their bones. Blood samples float in sealed tubes. Sleep patterns are recorded. Every movement is data. The biggest question scientists ask is simple: how long can humans safely live away from Earth? No one knows the full answer yet, but the ISS provides clues. Some astronauts return healthier than expected. Others return weaker. Some show mysterious changes in their DNA. Some recover quickly. Others take a long time to heal. Inside the ISS, the human body reveals secrets that may reshape medicine, not just for space travelers, but for everyone on Earth. The small particles that change everything. One of the most surprising discoveries inside the ISS comes from tiny particles: dust, bacteria, and even human cells. In zero gravity, these small particles behave strangely. Some bacteria grow faster, some grow slower, and become stronger or more resistant to medicine. Scientists realize that studying bacteria in space could help develop new medicines and understand old diseases in new ways. In another experiment, metal dust melts together without touching the bottom of a container. Scientists discover that without gravity, they can create new alloys, new materials that might one day be used to build stronger spacecraft or better technology on Earth. But alongside these discoveries, something disturbing begins happening in the ISS laboratories. Certain small particles, after weeks of floating inside sealed chambers, begin forming patterns, smooth shapes, spiral forms, and tiny organized structures that no one fully expected. Scientists on Earth ask for more samples. They request more testing. They demand more information. Something unusual is happening at the microscopic level, something that might reveal a deeper truth about life, matter, or biology itself. And while astronauts run these experiments, a different kind of danger grows unnoticed. A crack that should not exist. The small new crack discovered on the station's window continues to worry the crew. In zero gravity, a crack behaves differently. It does not spread downward or upward, it spreads in unpredictable directions, sometimes slowly, sometimes suddenly. The astronauts take pictures. They send them to mission control. Experts on the ground analyze them with urgency. And then a second crack appears, very small, barely visible, but new, 2 cracks in 2 days. The crew knows this is not normal. Something is stressing the window, something is pressing against the station from outside or maybe from inside. But orbital debris has not hit yet. The avoidance maneuver is still being planned. No impact has been detected. So where did the cracks come from? As the crew debates quietly, the station's lights flicker for a moment. Only a second, but long enough for everyone to notice. One astronaut floats closer to the window. Outside, the dark curve of Earth glows under the rising sun. Then something moves, not debris, not a reflection, something else. Something small, dark, and fast. It zips past the window and disappears into the shadows. The astronaut's heart races. He calls the commander. The crew gathers, staring at the window, trying to understand what they just saw. Before anyone can speak, the station's alarm suddenly blares, a loud, piercing sound that shakes the walls. A new message flashes on the control screen. Unidentified object near station. Possible impact trajectory. The crew turns toward the window, and in the distance, emerging slowly from the darkness, something begins to take shape. The alarm echoed through the metal walls of the International Space Station, turning the peaceful floating laboratory into a place of uncertainty and fear. Red warning lights blinked. The air hummed with tension. Every astronaut on board knew what this meant. Something was out there, close to the station, something their sensors could barely identify. The message on the screen repeated again. Unidentified object near station. Possible impact trajectory. The crew stared at the window where they had seen something flicker in the darkness. Space was supposed to be silent, empty, predictable. Objects in orbit followed rules scientists understood well. But this movement was different, too fast, too controlled, too strange. For a moment, everything inside the ISS went still. Outside, the Earth glowed under the first touch of sunlight. A thin golden line traced the planet's edge. The ISS moved like a silent giant over clouds and oceans. Inside, hearts beat faster. Minds raced. And then, the shadow moved again. The threat that should not exist, the astronauts watched closely. The unidentified object drifted in the distance, turning slowly, catching the light for a moment. It did not look like a rock. It did not look like a piece of old satellite. It did not match anything in the station's debris catalog. Mission Control on Earth sent rapid instructions. Stay calm, do not approach the window, activating external cameras. Everyone floated toward their stations. The commander called out their names, making sure everyone was safe and ready. Outside, the object drifted closer, silently, like a leaf carried by an invisible wind. But there was no wind in space, no breeze, no natural force that could move something like that. Inside the ISS, systems began recording everything: heat signatures, motion, trajectory. The computers processed the data, and one message appeared on the main screen. Object does not match known orbital material. The crew exchanged looks. If it wasn't debris, and it wasn't a satellite, and it wasn't a natural rock, then what was it? But before they could answer that question, the story of the ISS itself, the long history of the superstructure, began to speak through the cameras. Because while this new threat moved silently outside, the ISS faced another truth. Its future was already uncertain. Superstructure growing old for more than 20 years, the ISS had orbited Earth like a guardian. It had survived solar storms, power failures, micrometeoroids, and thousands of days of extreme temperature shifts, but nothing lasts forever. The station's panels had scars, its modules had scratches, its systems grew older every year. The ISS was aging. Engineers on Earth knew it. Astronauts in orbit knew it. And space itself seemed to know it. The constant expansion and contraction, caused by moving from sunlight into the cold shadow, strained the metal frames each day. Some parts were so old that astronauts joked the station was held together by science, hope, and duct tape. NASA had plans for new commercial stations. China had built the Tiangong. Private companies dreamed of hotels in orbit. The ISS was no longer the only outpost in space, but it was still the largest, the most important, the most experienced. And yet even the greatest structures must one day retire. Preparing for the future inside Mission Control, people work day and night planning the ISS's future. Where will astronauts go when the ISS ends? What parts can be saved? Should the station be deorbited safely? Can new stations take its place quickly? There were discussions about extending the ISS life to 2030, maybe beyond. But the cracks on the window, the growing external scars, and the aging systems made everything uncertain. Still, the ISS had one job left: to teach humanity how to live away from Earth. That mission was not finished. And now, as the unidentified object approached, the station's future felt more important and more fragile than ever. A crew under pressure inside the ISS, the commander studied the data. If the object came any closer, the crew might need to move into their spacecraft, the Dragon capsule and the Soyuz, ready to undock in case of emergency. But if they left the station too early, the ISS would continue its orbit unmanned, vulnerable, exposed. One astronaut floating near the laboratory window whispered, "Why is it moving like that?" Another replied softly, "It's almost like it's watching us." Their voices trembled, not from fear of the object, but from fear of the unknown. Humans are trained to understand danger, but what is more terrifying than danger? Mystery. The cameras reveal more finally, the external cameras locked onto the object. The image appeared on the screen. At first it was blurry, but then it sharpened. The object was small, dark silver, smooth, shaped almost like a flattened sphere or a metallic seed. It rotated slowly as if studying the station. The crew stared in disbelief. One astronaut whispered, "That's not natural." Another added, "And it's not from Earth." Mission Control tried to calm them. It could be debris from a spacecraft. It might just be reflecting light. But the crew knew better. It wasn't debris. Its movement was too controlled. Its shape was too perfect. And then something even more disturbing happened. The unexpected response: the object stopped moving. Objects in orbit never stop. They always follow a path. They always drift. They always obey physics. But this one froze in space as if anchored. The commander floated to the comms panel. He pressed a button. Ground the object. It's stationary. Mission Control fell silent for a moment. No one knew what to say. Then the station's lights flickered again, stronger this time. A vibration traveled through the walls. Panels rattled. Tools floated into the air as if something had disturbed the station's balance. Then a new alert flashed on the screen. Pressure drop detected Module 4. The astronauts spun around. Module 4, the science module, where some of their most important experiments were running, where they had recently detected unusual biological structures forming in microgravity, where samples were stored that scientists had never seen before. A leak in that module would be dangerous, very dangerous. The commander shouted, "All crew, seal the hatches." They moved fast, grabbing handles, closing doors, checking seals. The alarms grew louder. Outside, through the window, the object shifted very slightly, almost as if reacting to the pressure drop. Inside, the crew struggled to contain the leak. And then a new sound echoed through the ISS. Not the mechanical creak, not the click of pipes, not the hum of ventilators. This sound was different. A faint tapping, slow, rhythmic, coming from inside the walls. One astronaut froze, her eyes widened. The sound, it's coming from the science module. The tapping grew louder, tap, 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 like something inside was knocking or answering. Outside, the unidentified object moved again, this time directly toward the module that was leaking. The crew stared at the screen, helpless. As the object aligned itself with the station, the tapping stopped abruptly. A new message flashed. Unknown interface detected Module 4 exterior. The station shook. Lights went dark. The screen flickered. And in that final second before everything powered off, the cameras captured one last image, something metallic, attaching itself to the ISS.